All right, guys. I already passed out the note templates for you. So this will be our kind of our first, normal-ish day as far as kind of getting into a lesson and then a homework and that whole thing. So new to this year, as we're starting out with, we used to call this chapter 11, and maybe get to it, maybe not. The probability stuff. We're gonna cover this first off this year. So that's why I've marked it out on yours and called it 1.1. We'll just call it chapter 1, and it's all about probability. It's a pretty quick unit, and there are only 4 lessons. You've probably maybe seen some of it before. Some of it will be new, I'm sure. And if you have a graphing calculator, the computational piece will be a little bit easier. If not, you can do without, but work on getting those. Okay, so three ways to count sample spaces that we'll learn today. Counting principle, you've definitely seen that before. Permutations, maybe. Combinations, maybe you've seen it before. Counting principle basically just says that, looking at the tree diagram here with the pants and the shirt, there's three. Looks like there's 3 types of pants, 2 types of shirts. So it says we can simply take 3 times 2 to get 6 outfits. Right, so if we counted those from the tree diagram, you'd have 1, 2, 3, 4, 5, 6. Right, so that's basically the counting principle. As we look down at example 1, though, this would be kind of a rough tree diagram to make. If we have 3 English courses, 5 maths, 2 art, 4 history. How many ways could we choose one of each type, right? So basically in that case, we're just going to take 3 times 5 times 2 times 4. And obviously we can just easily type that in. 3 times 5 times 2 times 4 would be 120. So you can imagine that'd be a tough tree diagram to make if you had 120 items in your last column there. All right, a little bit more involved question here in example 2. It says the photos show Maryland license plates from 04 and 1912. How many more of the modern style license plates are there than the old ones? Okay, so for the new ones, it says we do 3 digits and then 3 letters and then 3 digits. So 6 spots overall. And the old ones, we only had 4 spots that were all digits. Okay, so if we're talking about letters, how many letters are there to choose from? 26. What about digits? How many digits are there? Thinking about a keypad on a phone. 10, right? Usually, sometimes people say 9, but we include 0 in there as well. All right, so for the Maryland license plates, then, if we have 3 letters to choose from, and I believe it says they can repeat, then each of those would be, 26. So we'd have, 26 times 26 times 26, right? So I'm just going to say 26 to the 3rd for my letters. And then for my digits, I'd have 10 to the 3rd. 10 times 10 times 10. Okay. I can just type that into my calculator as 26 times 26 times 26 times 10 times 10 times 10, or I can shorten that with the exponents. Give you a second to do that. You should be seeing the number 17,576,000. 17576,000. So lots of combinations there. Okay. Anybody need to see that on the calculator? Are we feeling okay? All right. What about for the old license plate model? What would we type in as far as filling those 4 spaces? Anybody? Yes, Eichenberger? Not 26 to the 4th. That'd be if we were doing letters. So if we're doing digits, what to the 4th? 10 to the 4th. That's right. So 10 to the 4th ways on the old license plate. So that'd just be a 1 with 4 zeros behind it. or 10,000. Okay. So now we have numbers to deal with. How many more is 17,576,000 than 10,000? So we'll just subtract there. So big number minus little number equals what? That number would be 17,566,000. Okay, you'll see we end up with some big numbers today. All right, another notation that you may or may not be familiar with is that exclamation point looking thing. It's on the back side, it sounds like. Go ahead and flip over, look at example 3A. Does anybody know what that exclamation looking point means? James? Factorial, right? I always try to make the joke that it doesn't mean 5. Like it's an exclamation point. You get it? Nobody ever laughs at that. You guys are all like, what's this crazy guy doing? But no, it means factorial. So what that literally means, 5 factorial means 5 times 4 times 3 times 2 times 1. You don't really need the times 1, but you can go ahead and say that means 5 times 4 times 3 times 2. If you want to put times 1, you can, but that's not going to change anything. Then we could just type that in to get 120. 5 factorial is equal to 120. Okay. Now, if you have a graphing calculator, this may be on a TI-30 as well, but here's where you find the factorial function on your calculator. So if I type 120, sorry, I wanted 5 there, 5, and then if I go to math, which is kind of upper left, if you're on a TI-83 or 84. Then probability, PROB or PRB if you're on a TI-83, option 4, and then I just have to type a little bit less. So it gives me the 120. All right, anybody need to see that again? Yeah, okay, one more time. We're gonna type 5, okay? Then we're gonna go to math, which on your screen is right there, okay? So math, and arrow over to probability. So math over to probability, and then the exclamation point looking thing. So I'm going to hit option 4. You can also arrow down there, then hit enter. Everybody good with me now? All right. So moving on. What if we did 12 factorial divided by 10 factorial? Well, if you had a graphing calculator, you could just type it in, but stay with me and think about this for a second. How could we sort that out? Okay. So 12 factorial, we're not going to write all this out, but that'd be 12 times 11 times 10 times 9, and I'm just going to put dot, 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 okay, because we know we can just keep going, right? What about 10 factorial, right? That would be 10 times 9 times dot, 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 right? Well, if we use our knowledge of fractions here, what's going to happen to from 10 times 9 times 8? What's going to happen to these upstairs with these downstairs? Right? They're going to cancel to 1, right? So all of this just cancels out basically, right? So what are we left with? 12 times 11 over 1 basically is it, right? So just 12 times 11 would be an easy way to type that in. Either way you type it in, though, you should get 132. 132. C is a little bit tougher. I'm going to give you a second to see what you can do on it. So it's 11 factorial divided by 7 factorial times 2 factorial. So you could just type it in directly. If you are using the factorial key, let me say this, though. If you're dividing by a product like you are here, you're going to want to have this in parentheses. If you're just typing in using the factorial key, you're going to want to open a parentheses before the 7. Okay? another like 10 seconds. If you can figure it out, great. If not, we'll look at it together. Sometimes you got to play around with these things to make it work right. We figure out where the parentheses go, where all the functions, stuff like that. Okay, so if I'm not using a graphing calculator here, I'm going to look at these two together and then worry about the 2 at the end, right? So the 7 factorial on the denominator is gonna cancel that part of the 11 factorial. Then we'll go from there, right? So if I do that cancellation, then I have 11, 10 times 9 times 8, and then 7, 6, 5, 4, 3, 2, 1 are all gone, right? Because it canceled. What I haven't canceled yet are the 2 factorial. Really just 2. I'm just going to write that as 2 because 2 times 1 is 2. And then if I wanted to, I could do another cancellation, right? I can get fancy here if I want. Make that a 1, make that a 4. And then just 11 times 9 times 10 times 9 times 4. Okay, that gets a little tricky. I get that. But you guys had a little bit of time to do it. No matter how you typed it in, if you got the number 3,960, you did it right. So that's good. Most probably did. Does anybody have any questions? Okay. And again, I could do the cancellation, or I could try to type it in as it's written, right? So that would look like this: 11, and then math, and then probability, and then factorial divided by. Here's where I got to be slick though. If I'm just typing it in, I got to know I got to open parentheses or it's going to be messed up, right? So then 7, and then that whole bit again over to probability. Option 4, and then 2 is just, I could just hit times 2 or 2 factorial, which would waste time. See, I get that same number, 3,960. Okay. Any questions? All right, moving on. So your 2 main things in this lesson are permutations and combinations. So a permutation is an arrangement of items in a particular order. So I'm gonna kind of circle this particular order, and I'm just gonna write. You'll hear me say this: order matters. So like the Olympics is going on right now, right? So the order in which the participants finish the race matters, right? So then this would be like a permutation kind of thing, right? Okay, so you'll see me use this notation right here, an N and then a P and then an R, right? So N is the number in my last example who would be like running the race. Like, again, if you're watching the Olympics, what do they race on a I guess it depends on the race, but 6, 8 people, right? So if we said how many ways can 6 people finish first, second, and third? 6 would be my N number, and then 3 would be my R number. Okay, I'll show you what I mean in a second. All right, so the font on this looks a little funky. The 12 and the 8 should be smaller, so let's just mark that out and write it how it normally should look. Little 12, big P, little 8. All right, so if I'm doing this without a graphing calculator, that's just going to be 12 factorial divided by 4 factorial. Where'd I get 4 factorial? How can I get 4 from using 12 and 8? Anybody? Yeah. 12 minus 8, right? So 12 minus 8. So again, if we work that out, we're going to get a really large number. Okay, that'd be like 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5, and that's it. Okay. So the number would be 19,958,000. 19,958 400. So 12P8 equals that. Here's how you can just type it in using the 12 and the 8. Okay, here's how you can type it in. On the newer TI-30, you don't have to type the 12 first. On the old, on the newer TI-84, you don't type anything first. You just go to math, over to probability. There's that NPR key, so option 2. Then you can type in your numbers. So 12 there, 8. Whoops, I messed that up. Sorry about that. Let's try that one more time. So NPR, so option 2, 12 there, 8 there. There's that number. Okay. You don't have to have the graphing calculator. You just have to have more knowledge of how to work these out. Okay. You guys tried 20p5. I'll go over the answer here in just a second. 20p5. This number, just if you're wondering if it's right before you write it down, is in the millions, and it's closer to 2 million than 1 million. So if you got a number like that, then you got it. About 10 more seconds. All right, that number is 1860480. So 1.86 million. Okay. So we went over how to type that in using a graphing calculator. It looks like a lot of you guys have that. That's great. If you don't have a graphing calculator, the easiest way to type this in would be 20 times 19 times 18 times 17. So we're going 1, 2, 3, 4, 5 spots. Okay. That's what you can type in. Hopefully that helps. Okay. All right. So let's go ahead and let's skip example 5 and do example 6. So what would a word problem where we would use permutations look like? It would look something like this. 10 students are in a race. So like the generic example I used at the beginning. How many ways could they finish first, second, and third, right? So using our permutation notation, that would be 10p3 because we're filling 3 spots, right? So you could type it in that way. If you don't have a graphing calculator, you're going to type 10 times 9 times 8. And that would be 720. 720. Any questions on that one? All right. Go ahead and try 7. Go ahead and do example 7. I'll give you about 30 seconds on that one. So first of all, what's my permutation notation? And then second of all, do I have the computational or the calculator skills to work that out, right? It's kind of a two-part thing. All right, so the answer here, the overall simplified answer here that you would type in if this were an Alex question would be 6,840. So if you got 6,840, you got it right, okay? If not, or if you got something else, here's how I get there, okay? So we have 20 to choose from. It's a permutation because president is different than vice president, right? So it's a permutation, and then we're choosing 3 spots, right? That number wasn't listed, but we have president, vice, and secretary. So 3 positions. So in my calculator, I can do 20p3 if I have a graphing calculator. If not, I'm typing in 20 times 19 times 18 to get the 6840. Everybody with me? Questions? All right. So example 9 and 10 are kind of the same, but let's just look at example 9 and see how it's slightly different. It says, how many ways can you arrange the letters of the word happy? Okay, so the trick with this one is Well, what's gonna throw me off here is that I have repeated letters. Okay, so let's see what it says about that. It uses the word incidental here. So if you're assigning position to things and some of the items are incidental, and then we have some formatting errors. So let's just know that there are repeats, and that's what's throwing us off. And here's how we throw out the repeats. Okay, here's how we throw out the repeated arrangements. Sorry, struggling with my words today. All right, so what we would do is, if it were a different 5-letter word like Corey that didn't have any repeats, we would just do 5 factorial, okay? Because there are 5 letters in Corey. Same as happy. So we're going to do 5 factorial, but now we're going to divide to take out the repeats, all right? So we're going to divide by, I can't see my notes here. Okay, so we're going to divide by how many repeated letters there are, factorial. So there are 2 repeated letters. So so that's just going to be 5 times 4 times 3, and then 2 factorials canceled out. Okay. So overall, that would just be 60. Whereas if I didn't have any repeats, it'd be 120. Okay, so cuts it in half. I don't know that you'll run into that on your homework, but if you do. Either way, it's a good segue into our combinations, which is where we'll finish. So just like a permutation, a combination is also an arrangement of items. And then I want you to kind of highlight order doesn't matter. Order doesn't matter. So this is when you're just pulling like a random group of like, say I have a class of 32 here. I want to pull just how many ways can I pull a random group of 3? So we want to throw out any repeats, right? Because a group of I don't know your all names well enough right now, but a group of Sam and then Johnny and then Sarah is the same as the group of Sarah and then Johnny and then whoever the other guy said was, right? Order doesn't matter. Okay, so we got to throw out the repeats basically. Here's our formula. Okay, and it's kind of like what we did there up top there. Okay. All right, so let's go ahead and try to do 15C3. And again, this should show up more like little 15, big C, little 3. Okay. All right, so what I do there is, if it were 15P3, then I would have 15 times 14 times 13, right? But here, I also add in so 15 factorial divided by 12 factorial times 3 factorial. Okay, so that throws out the repeats. This is the new addition here. This is our thing that throws out the repeats. So without a graphing calculator, we're thinking, okay, the 12 factorial is gonna leave me with, I think this is the easiest way to think through it, 15, 14, 13. And then we can divide that by 3 factorial, which is just 6. Okay. With the graphing calculator, I'm just going to simply type it as it's written, right? So I'm going to go to math. I'm going to go to math. Sorry, I messed that up. Math, and then over to probability. And the combination one, so option 3, then I'm going to type in my numbers, right? So my numbers, again, were 15 and 3. The number here is 455. All right, so a little more complicated without the graphing calculator here. You try 12C9. 12C9. See what you can come up with. All right, so should it be something like 12 factorial over 9 factorial times 3 factorial? The number is, for those of you who just type it in, 220. 220. Anybody need to see that worked out in more detail? Okay, almost done, I promise. Sorry, this is kind of a long first lesson. You guys are doing a great job staying with me. Good stuff out there. So I'll do example 12. You'll try 13, and then we'll probably cut it off there. Okay. All right. So, in how many ways can you select 3 Scrabble tiles from a set of 5? I guess unless they say there are repeated letters in there, or maybe there aren't in Scrabble. I don't know Scrabble that well. Assume there aren't any repeats. Okay. So, just a random group of 3. Okay. So this would be big number is always on the outside. So that's what we're choosing from. So this would be 5, choose 3. So that's the setup. If we have a graphing calculator, we just start typing at this point. If not, okay, how do we kind of work this out? So it'd be, 5 factorial divided by 5 minus 3, which is 2 factorial times 3 factorial. Okay, and then again, do you have the skill to do it from there? So there can be a lot to this, but does anybody know what the number is? The simplified number? Bless you. Blank, did you have it? 10. I thought I saw you mouth it. So 10 is correct. Very good. All right, you guys go ahead and try that last one. How many ways can you select a 3-person committee from a group of 10 people? Just so you know if you're in the right ballpark, this number is somewhere between 1 and 200 ways. Okay, or closer to 100. So if you got a number that fits that bill, you probably did it right. All right. So what we wanted to do here was 10C3, and 10C3 is equal to, anybody know my number? Yes, 120. Anybody need to see how I get from 10C3 to 120? Okay, we'll kind of cut it off there. There is example 14 through 16. We're just going to skip those. I'll assign you an Alex with this, and ultimately it's due the day before whenever we take the quiz or the test is, okay? I would try to do what you can as it comes, though. Let me stop this recording real quick.